Hi, I'm Robert Coleman. I'm a Senior Applications Manager at Texas Instruments. Welcome to Power Tips.
Welcome to Power Tip 38. In this Power Tip, we're going to take a look at a simple latch circuit. This latch circuit can be used in offline power supplies to provide fault protection. The latch is composed of 2 transistors and 2 resistors. A very simple circuit, very inexpensive, maybe costs 4 cents in production. This is a basic SCR structure, and you can trigger it in 2 places. Either you trigger it by injecting current into the base of Q2, or you trigger it by taking current out of the base of Q1. If you inject current into the base of Q2, the device will start to turn on, and it'll draw current from the base of Q1, and that turns Q1 on, and it's kind of a regenerative action that latches the devices on. And the devices will remain on as long as there's sufficient current applied to the circuit. You have to have at least 0.6 of a volt across the base emitter of each of the transistor, and so that means that the current has to be greater than VBE divided by the sum of the resistances for the circuit to remain latched. This is an example of where you might use this last circuit. This is an offline power supply. There's a high voltage applied from the input here. And to start up this power supply, a little bit of the input voltage is turned into current, and it charges this bias capacitor here. Once the bias capacitor gets to a suitable voltage, the control IC turns on and starts switching the MOSFET. In this particular example, we've used our latch circuit to provide overvoltage protection for the power supply. You can see the latch in the bottom of the slide here, and over to the right, we have an optocoupled transistor connected to some Zeners that are connected across the output voltage. So in the event the output voltage goes too high, the Zener diodes start to conduct, turns the optocoupler on, and that pulls current out of the base of Q4, and that starts the latch action. And then the current builds in the SCR, it discharges the bias capacitor, and then eventually the control IC turns off because it's reached its undervoltage lockout limit. And this circuit can be made either latching or non-latching. That is, in the event of a fault, it'll shut down the power supply and require the power supply to be recycled to start providing power again. Or in the case that it doesn't latch, it will discharge to the point that the undervoltage lockout of the control IC turns off the power supply, and it'll continue the discharge. And if the current is limited to the value that we talked about in the previous slide, it'll turn off, and that allows the voltage on the bias supply to start to rise again. The control IC turns on, and then the whole process starts over again. You can use this device as an overvoltage latch. You can use it as a current latch, and then also you can monitor the input voltage and turn down the power supply if the input voltage gets too high. This latch can find many applications in this power supply. Well, thanks for your attention on this power tip. There are many more power tips on the web. You can go to the Power Management Design line and search power tips, or you can click on the link to all articles in the description section of this video. Thank you.